There's something strangely comforting about the night, not because life suddenly becomes easier, but because, for a few quiet hours, the world finally asks less of you. No messages to answer, no expectations to carry, no pressure to keep pushing through exhaustion. And somewhere in that darkness, your brain begins doing work that waking life rarely allows. Tonight, as your body rests beneath the surface of awareness, billions of neural connections will begin reorganizing themselves. Stress signals may soften. Emotional intensity may begin to loosen. Memories will be sorted, filtered, and stored. Even parts of your nervous system that have remained tense for days or years may briefly enter a state of repair. And perhaps most surprisingly of all, much of this happens without your conscious effort. Your sleeping brain is not inactive. It is deeply, astonishingly alive. Welcome to Better Sleep Daily. Tonight, we're going to slowly explore the hidden science of what your brain heals while you sleep. Not in a rushed way, not in a cold academic way, but gently, calmly, like a quiet conversation late at night when your mind no longer has the energy to pretend it's okay. So wherever you are right now, allow yourself to set everything down for a little while. The overthinking, the unfinished tasks, the pressure to solve tomorrow before tomorrow arrives. Your nervous system has been carrying more than most people can see, and maybe more than even you fully realize. Take one slow breath in and another. There is nothing you need to achieve here tonight, only something to understand. Your brain may be working much harder to heal you than you think. Sleep has often been misunderstood as a passive state, a shutdown mode, a period where the body simply turns off until morning. But modern neuroscience tells a very different story. The brain during sleep is extraordinarily active. In some regions, brain activity becomes nearly as intense as it is during waking life. Only now, instead of reacting to the outside world, the brain turns inward, toward repair, toward regulation, toward emotional processing, toward restoration. And for people living under chronic stress, this hidden nighttime work may be more important than ever. Researchers now believe that deep sleep plays a critical role in regulating emotional stability, nervous system recovery, immune function, memory consolidation, hormonal balance, and even the brain's ability to clear metabolic waste. In other words, sleep is not simply rest. Sleep is maintenance, repair, protection, and sometimes survival. This may help explain why prolonged sleep deprivation affects people so deeply emotionally. After even one poor night of sleep, the emotional centers of the brain become significantly more reactive. The amygdala, the brain's threat detection system, begins responding more intensely to negative experiences. Small stresses feel larger. Anxiety feels heavier. Thoughts become harder to regulate. And many people begin blaming themselves for this shift, without realizing their exhausted brain is functioning in a biologically different state. Your brain was never designed to endure endless stress without recovery. And yet millions of people try to do exactly that every day, especially at night, when distractions disappear and unresolved emotions finally become audible. This is one reason nighttime anxiety can feel so overwhelming. During the day, the brain is occupied, stimulated, distracted. But in darkness, with fewer external demands competing for attention, the nervous system often reveals what it has been suppressing. For some people, this appears as racing thoughts. For others, a feeling of unexplained dread, a sudden wave of sadness, restlessness, or the strange exhaustion of feeling tired beyond words, while still being unable to sleep. And what scientists discovered next about the sleeping brain became even more fascinating, because the brain does not simply endure emotional experiences during the day, it continues processing them at night. In fact, researchers now believe that one of sleep's most important functions may be emotional recalibration, a kind of overnight emotional processing system. While you sleep, the brain appears to revisit emotionally charged experiences and slowly reduce their emotional intensity over time. Not erase them, not delete them, but soften their sharpest edges, which means something remarkable may be happening during healthy sleep. Your brain could be helping you emotionally survive your life. And perhaps this explains something many people have quietly felt for years. Why certain problems seem unbearable at night, but slightly more manageable in the morning. Sleep changes emotional perception, not because your problems disappear, but because your brain regains some of its ability to regulate them. And that process begins far earlier than most people realize. Even within the very first stages of sleep, the brain begins transitioning away from external awareness. Brainwave patterns slow, muscle tension decreases, stress chemistry gradually shifts. The nervous system starts moving away from survival-oriented alertness and toward restoration, unless, of course, the brain still believes danger is present. And this is where modern stress becomes so disruptive to sleep, because your nervous system does not only respond to physical danger, it also responds to emotional uncertainty, financial pressure, loneliness, burnout, chronic overstimulation, unresolved fear, emotional exhaustion. The body often experiences these conditions as forms of ongoing threat. And when the brain perceives threat, Deep restorative sleep becomes harder to fully enter, not because your body is failing, but because your nervous system is trying to protect you, even if that protection has become exhausting itself. And strangely enough, understanding this often helps people suffer less, because many chronic insomniacs secretly believe something's wrong with them as a person, that they are weak, broken, failing at rest, when in reality their brain may simply be stuck in a prolonged state of hypervigilance, a survival state the modern world quietly reinforces. And tonight, we're going to explore what happens inside that exhausted brain after the lights go out. What your nervous system continues doing while you sleep. Why emotional memories behave differently overnight. Why deep sleep is so biologically restorative. And why your brain may still be trying, even now, to guide you back toward balance. So for now, there is nothing you need to force, nothing you need to solve immediately. Just listen, breathe slowly, and let your mind rest inside the quiet intelligence of the sleeping brain. Because healing is often far less dramatic than people imagine. Sometimes it looks like darkness, stillness, and a tired nervous system finally being allowed to exhale. And as the night deepens, your brain begins moving through a remarkable sequence of internal states. Not random states, not empty unconsciousness, but carefully organized neurological cycles that researchers are still trying to fully understand. Each night, your brain passes through several different stages of sleep. Light sleep, deep slow wave sleep, and REM sleep, the stage most associated with vivid dreaming and emotional processing. These stages repeat throughout the night in cycles, usually about every 90 minutes, almost like tides moving in and out beneath awareness. And each stage appears to serve a different restorative purpose. Some forms of healing happen earlier in the night. Others emerge closer to morning, which means your sleeping brain is not doing one single task, but many, quietly, simultaneously, continuously adjusting the balance between memory, emotion, stress, and recovery. Scientists now believe different types of information are processed during different stages of sleep. Deep slow-wave sleep appears especially important for stabilizing factual memories and restoring the body physically. REM sleep, on the other hand, seems more connected to emotional regulation, creativity, pattern recognition, and the integration of complex experiences. And perhaps this explains why emotionally overwhelming periods of life often disturb REM sleep first. The brain struggles to safely process what it has not yet emotionally resolved. For people living with chronic stress or anxiety, This cycle can become exhausting. The body feels tired, but the nervous system remains alert. The mind wants rest, while another part of the brain quietly continues scanning for danger. And yet, even then, the sleeping brain continues trying to help. One of the most important structures involved in this process is the hippocampus, a small curved region deep inside the brain that plays a central role in forming new memories. Throughout the day, the hippocampus works constantly, absorbing conversations, faces, worries, information, moments of embarrassment, stressful interactions, tiny emotional details most people forget they even noticed. In many ways, it functions like a temporary holding space for experience. But the hippocampus was never designed to permanently carry everything. If it attempted to store every detail equally, the brain would quickly become overwhelmed. So during deep sleep, something extraordinary begins happening. The hippocampus starts replaying fragments of recent experience. Patterns of neural activity repeat themselves again and again throughout the night, almost like the brain quietly reviewing parts of the day behind the curtain of consciousness. And over time, important information is gradually transferred outward into longer-term storage networks across the cortex. Neuroscientists sometimes refer to this as systems consolidation. But emotionally, it may feel more human than technical, because what your brain is really asking all night long is, what matters enough to keep? And surprisingly, your brain does not make these decisions logically alone. It prioritizes emotionally significant experiences, moments tied to fear, relief, connection, embarrassment, stress, love, pain. The brain appears far more likely to preserve information connected to emotion than emotionally neutral details, which means your nervous system is not simply recording events, it is recording meaning. This may be one reason emotionally difficult days feel so mentally exhausting. Your brain spends the night trying to process experiences that carried emotional weight, trying to organize them, contain them, understand them, and perhaps soften them enough for you to continue moving forward. Without this filtering system, daily life would become neurologically unbearable. Every memory would compete equally for attention. Every detail would remain emotionally loud. Every moment would feel unresolved. So forgetting, in many ways, is not failure. It is protection. The sleeping brain is constantly deciding what can safely fade, so that what truly matters can remain accessible. And one of the earliest discoveries proving that sleep actively improves brain function came from surprisingly simple experiments. Researchers taught participants small physical tasks, finger-tapping sequences, simple movement patterns, skills similar to learning a short piano exercise. Then they measured performance after a full night of sleep. What they discovered changed how scientists understood learning itself. People who slept improved significantly more than those who remained awake for the same amount of time. Not because they practiced more, but because their sleeping brain continued refining the skill overnight, without conscious effort, without additional repetition, as though the brain had quietly kept working in darkness long after the person believed the learning had stopped. And this idea deeply challenged the modern obsession with constant effort, because neuroscience began revealing something many exhausted people desperately need to hear. Rest is not the opposite of progress. Sometimes rest is where progress finally becomes possible, especially for the overwhelmed nervous system, especially for the emotionally exhausted brain. Deep, slow-wave sleep appears to play a particularly important role in this process. During this stage, the brain produces large synchronized electrical patterns called delta waves. Slow, powerful, rhythmic pulses moving across enormous networks of neurons. And researchers believe these slow oscillations help coordinate communication between memory centers and long-term storage systems throughout the brain, almost like a carefully timed nighttime conversation between different regions of the mind. Signals replay, connections strengthen, useful patterns stabilize, and unnecessary noise begins fading into the background. It is astonishingly organized for something happening completely outside conscious awareness. And perhaps even more astonishing, this restorative intelligence has been quietly protecting human beings every night for thousands of years, long before neuroscience could measure it, long before brain scans could visualize it. Your brain already knew how to heal in darkness. The modern world simply became noisy enough for many people to forget. As these slow waves travel through the sleeping brain, other rhythms begin appearing alongside them. Small bursts of activity, brief pulses of electrical coordination, tiny patterns so fast and delicate that for many years scientists barely understood what they were seeing. And yet, these quiet signals may be part of one of the brain's most sophisticated nighttime repair systems. During lighter stages of non-REM sleep, the brain produces sudden bursts of neural activity known as sleep spindles. Short, rapid oscillations lasting only a second or two. They appear and disappear almost like sparks in darkness. Easy to miss, but deeply important. Researchers now believe sleep spindles help stabilize communication between different brain regions while memories are being processed, almost like temporary bridges connecting fragile new experiences to longer-term neural networks. And remarkably, people who naturally produce more sleep spindles often perform better on certain forms of learning, memory retention, and cognitive flexibility. The brain, even while asleep, seems to be actively coordinating which experiences become more permanent, which skills become smoother, which emotional associations become stronger, and perhaps most importantly, which experiences begin integrating into your deeper understanding of life itself. Scientists have even experimented with gently influencing these rhythms during sleep. Soft sounds timed to match slow brain waves, subtle electrical stimulation designed to support memory consolidation. Early findings suggest that under certain conditions, the sleeping brain may become even more efficient at organizing information. But perhaps the most fascinating part is not the technology. It is what these discoveries reveal about the brain itself. Because the sleeping mind is not merely replaying life like a recording, it is interpreting it, restructuring it, searching for patterns hidden beneath individual experiences. This may explain something profoundly human. Why people sometimes sleep on a problem and wake with unexpected clarity. During sleep, the brain appears capable of transforming isolated experiences into broader understanding. Researchers observed this in studies involving language learning and pattern recognition. Participants exposed to hidden grammatical systems or repeating structures often became better at understanding the underlying rules after sleep, even when they had never consciously recognized those rules while awake. The sleeping brain had quietly extracted the pattern beneath the surface. Without effort, without conscious analysis, almost as though sleep allows the brain to step back from details and finally see the larger picture. And emotionally, human beings may do something very similar. A difficult conversation, a painful memory, a stressful season of life. In waking hours, these experiences can feel fragmented and overwhelming. But over time, sleep may slowly help the brain organize emotional chaos into meaning. Not immediately, not perfectly, but gradually. The sleeping brain seems deeply invested in helping us adapt to our lives. Not just survive individual moments, but understand them well enough to continue forward. And this changes how we think about learning itself, because perhaps the brain's greatest nighttime skill is not memorization, but integration, turning isolated experiences into usable wisdom, turning emotional noise into understanding, turning survival into adaptation. The more scientists study sleep, the more astonishing this process becomes. The brain does not simply store the day. It selects from it, replays it, strengthens certain parts, softens others, extracts patterns, builds associations, and sometimes transforms raw experience into something more stable and enduring than what originally occurred. The waking hours gather material, but the sleeping hours shape it. And perhaps this is why emotionally overwhelmed people often feel mentally heavier after long periods of poor sleep, because the brain loses access to part of its natural overnight processing system. Experiences accumulate faster than they can be integrated. Stress remains emotionally unfinished. Thoughts stay louder, feelings remain sharper, and the nervous system begins carrying more unresolved activation from one day into the next. Many people blame themselves for this exhaustion, but neuroscience suggests something far more compassionate. The brain was never meant to process endless emotional stimulation without deep recovery. Sleep is not optional maintenance for the human mind. It is part of how emotional balance is biologically preserved. And this relationship between sleep, healing, and learning changes throughout life. Infants, for example, spend enormous amounts of time in REM sleep, far more than adults. Their rapidly developing brains appear to require extraordinary amounts of nighttime neural organization as they absorb language, emotional attachment, movement, sensory information, and social understanding at astonishing speed. In many ways, childhood is a period of massive neurological construction, and sleep becomes one of the brain's primary building environments. As people age, however, sleep architecture gradually changes. Deep sleep often becomes lighter. REM sleep may shorten. Sleep spindle activity can decrease over time, and many older adults begin noticing that learning new skills, recovering from stress, or maintaining uninterrupted sleep requires more effort than it once did. This is not weakness. It is biology. The aging brain is still adaptive, still capable of growth, still capable of healing. But it may require more consistency, more calm, and more recovery to do what once happened more automatically. And perhaps there is something strangely comforting in that realization, because the architecture of sleep seems to mirror the architecture of human life itself. In youth, the brain expands rapidly outward into the world, absorbing everything, learning constantly, building identity, and later in life, sleep may become less about expansion and more about preservation, restoration, emotional regulation, repair, a quieter kind of intelligence, one that values peace more than speed. And perhaps this is why so many exhausted adults secretly long not only for sleep, but for relief, for stillness, for a nervous system that no longer feels constantly braced against life. And tonight, somewhere beneath consciousness, your brain may already be trying to move gently in that direction. Not all memories are stored in the same way. And perhaps more importantly, not all memories ask the brain for the same kind of healing. Some memories are clear and deliberate, the kind you can consciously describe. A conversation from years ago, the name of a childhood friend, the meaning of a familiar word, a specific moment that still carries emotional weight. Neuroscientists often call these declarative memories, experiences and information the conscious mind can intentionally recall. But there is another kind of memory that lives deeper, beneath awareness. The memory of how to drive home without thinking. How your fingers know where the keys are on a keyboard. How the body remembers fear. How tension settles automatically into the shoulders after years of stress. These are procedural and implicit memories. Patterns the nervous system learns through repetition, emotion, and survival. And sleep appears to support both forms of memory, though through different nighttime processes. During deep, slow-wave sleep, communication between the hippocampus and the cortex helps stabilize conscious memories and experiences. But REM sleep seems especially connected to emotional learning, habit formation, movement patterns, creativity, and subconscious integration. In other words, some parts of sleep help you remember facts. Other parts help shape who you become. And perhaps this is why emotionally significant periods of life affect sleep so deeply. Because the brain is not only trying to remember what happened, it is trying to understand how to carry it. Researchers studying memory have discovered something extraordinary about this nighttime processing system. The sleeping brain remains surprisingly responsive to subtle information from the outside world, even after consciousness fades. In experiments involving targeted memory reactivation, scientists paired certain learning experiences with gentle sensory cues, a quiet tone, a faint scent, a subtle sound repeated during learning. Then later, while participants slept, those same cues were softly reintroduced without waking them. And remarkably, the brain often responded by preferentially replaying and strengthening the associated memories during sleep, as though the sleeping mind quietly recognized familiar signals and resumed processing them in darkness. This has been linked to improvements in vocabulary learning, spatial memory, emotional processing, and skill retention, which means something profoundly fascinating may be true. The sleeping brain continues listening long after awareness disappears. not listening in the ordinary sense, but remaining quietly receptive to patterns, signals, and emotional meaning. And perhaps this helps